I think it'd be rude. But that's purposely good. Everything like, I think that's the way you did. Yes.
Salary.
When I go up there. Maybe cheated something. She's. That's what big bros would. See, but this is only last time for I asked her a question. And I told her my question. She started explaining it. I'm like, I asked her.
Okay, so I need everyone, thumbs up on the wall there. Thanks, guys.
Be serious.
Thumbs up. Again, we're ahead with our notes. We should be able to finish all of our notes by today. And tomorrow I'll have a review sheet. And I also have another take-home review sheet that you can take home and work on Tuesday night, and then Wednesday the check-in quiz. I think the last thing we did was on page 20. 22. Okay, we did the top part, right? Okay, all right, so let's look at number 2 together. This is on page 22. And we'll just go through the process. Make sure, make sure we still remember all of our steps. So we'll go number 2 here. The scores on the intelligence quotient, IQ, tests are normally distributed. And so we know it's going to be along that distribution curve. With a mean of 100 and a standard deviation of 15. So we can go ahead and draw our bell curve. Seven vertical lines. There's one line down the middle, and then 3 to the left, and 3 to the right. The mean is going to be your middle, which is 100. That's your X bar. Your standard deviation is 15, so your sigma, it's like an O with a tail there. So we're going to be adding or subtracting 15 from the center. And moving left and right. So starting with 100. And then we have to understand our numbers there. The middle is going to be the largest, 34%. And then 13.5. And then 2.35. And then 0.15%. Okay, part B, what's the probability that a person will score at least 121? The problem is easier if something landed directly on the standard deviation, right? But here, at least 121 We know it's gonna be somewhere between, and we can estimate, but we're gonna use z-score so we can figure out the exact number. So first, let's talk about here though, at least 121, what does that mean? Anything above, right? Anything above, so 121 or higher. Okay. All right, so we're gonna use z-score because z-score is gonna help us figure out what the exact percentage is. Because it's landing, I mean, we can estimate, but we're not getting an exact value. So we'll first find our z-score. Our z-score is x minus x bar divided by sigma. The x is the number in question, the 121. The x bar is the mean, 100. Sigma is 15. So we use our calculator here. Let's figure out the z-score. Okay, we'll get a decimal number. What'd you guys get? 1.4, okay. Okay, so that's just the z-score. It doesn't tell us the probability just yet. So what we're going to do is we're going to go to our table, and that table is at the very front of your packet. It's either page 2 or page 3 of your packet. You're going to be looking for 1.4, positive 1.4. So anything positive is going to be on page 3. So positive 1.4. I see 1.4. It doesn't give me any other, it doesn't give me a tenth, so it's basically 1.40. So 1.40 is this 0.9192. You guys see that? So anything here, if it was like 1.41, then I got to look at this second column, right? 1.42, 1.43, 1.44. The 100th place will go to the right, but this is 1.40. So we're looking at that first column. So 0.9192. Now we understand that 0.9192 is for less than. But that's not what we want, right? So understand that if you do your z-score table, it's always going to give you less than. Right? And if you have to do greater than, you got to make an adjustment because the 91% is for people who scored up to 121. But I want at least 121, which is 121 or higher. So how can I make an adjustment so that I'm not getting to a true value? Good. So I know that 91% is here. That means the remaining 10% or 9% is on the other side. So if you want the other side of the data, then you just subtract from 1. Now understand that this is the probability. Okay. But if I want to find the percentage, I know it's not asking for the percentage. If I were asking for the percentage of the students who scored above 121, what would that percentage be? 0.808%. Okay, the decimal is always going to be 2 places off. So if I want to get to a percentage, it's always going to feel like a larger number because you're going to move that decimal over to the right. But if I have a percentage, I'm trying to get to a probability, I got to move to the left. Now, anything in the table is always giving you probability. Just want you to understand, what this number means in relation to a percentage. Oh, yeah.
In my calculator, 0.0808. That's what I.
Oh, okay. Let me see.
I thought it was wrong.
Oh, okay. Okay. Sorry. 0.08. My bad. I added 2 zeros. You're right. 0.0808. Which, if I were to create a decimal version, sorry, a percentage version, it'll be 8.08. Yeah, there we go. Next. Yeah, that makes more sense, right? Because 91% scores less than, that is around 8% should score more than. Okay. Next. Okay, part C, what's the probability that person will score no more than 79? So rephrase that a different way. Yeah, less than or equal to, right? So 79 or less. Now, the nice thing about the or less is that whatever you get from the table is your answer. No need to make an adjustment if it's less than. If it's greater than, I gotta make the adjustment. If it's between, I gotta subtract those percentages. The easiest one is when it says less than. Okay, same formula, x minus x bar. Because if you look, 79 doesn't land at a nice interval, so we don't want to just estimate, we want to find the exact value. The x is different, but the x bar and the sigma is the same. Okay, negative 1.4. We go to our table on page 2, negative 1.4.0808. It just happens to be the same number as above. This is the coincidence. Okay, what's the probability that a person will score between 92 and 100 and 111? Yes.
If it's like, if it's asking, less than, can you just look at the negative side?
Yeah, someone was asking about that. It should work out, but because everything should be symmetrical. But so yeah, you could look at the negative side, but I'm just always going to follow whatever the number they give me and make that adjustment there. Yeah. Okay, what's probably between with a person that scored between 92 and 100? So what we're going to do is we're going to find z-scores for both those numbers, find the probability for both those numbers. Then we do what with those probabilities? Subtract. That's right. Larger minus the smaller. If you get a negative, you know that you just have to change the positive. I mean, you just flip the order, so you can still get to the answer even if you subtract. But just make sure you don't subtract the z-scores from each other. You subtract the probability. So we gotta find each of these probabilities individually first, and then you can subtract them. I'll call it Z1 and Z2. Okay. Negative 0.53, negative 0.53. .2981. Okay, for the 111.73, that's positive 0.73. So when we look on page 3, 0.73, 0.7, 0, 0.71, 0.72, 0.73. So now that I'm sitting at my probabilities, now I can subtract these, and that will give me my answer for what's between. Now, if I were to ask you for the percentage, what would that look like? 46.92%. Okay, part C feels more complicated because we're working backward. Okay, so imagine if I gave you this percentage to begin, or let's say I gave you 8% to begin with. Okay, and then I just want you to work backwards to find that 121. So what you would do is you get that 8.08%, convert it to a decimal. Look at the z-score table to figure out what is a z-score that's associated with that probability. Once you find that probability, plug it in for z, and then cross multiply and figure out if the x value is 121. So, working backwards is not as intuitive, but let's practice that, what that looks like. So it says, what is the minimum score someone would have to, or what is minimum score, what minimum score would someone need to score higher than 80% of those taking an IQ test? So, what score will allow that person to be at the 80th percentile or 80th percentile or higher? So, right, we're working backwards here. We're going to find the z-score associated with that probability, and then from there, we're going to kind of work backwards to solve for x. Now, 80% is the same thing as what? The probability is what? 0.8, okay, 0.80, okay, so now 0.80. If you look at your page 2, look at all the probabilities are less than 50%. Right? Anything above 50% is going to be on page 3. So we're going to just, it's not going to be exact. We're just trying to find one that's as close as we can get. Okay, so look at all your probability here. What's the z-score that's closest to 80%? Yeah, so you can either do 0.85 or 0.84. You can make an argument for either. Well, I think 0.84 may be a little closer, right? This one is only 0.005 away. This one's a little further out, so our z-score is going to be 0.84, right? We're trying to find, we can't find exactly 0.80, but we can get close to it. As close as we can get is 0.84 z-score. Are you okay with that? Okay, so z-score is 0.84. We're working backwards, so that's what feels more difficult here. Now, there's a z-score formula, which is x minus x bar over sigma. We're going to replace z with 0.84. We're going to replace x bar with 100. We're going to replace sigma with 15, and then we'll cross multiply and we'll solve for x. And replace z, replace x bar with replace sigma. Then I should be able to just work my equation and solve for x. 0.84 times 15 is 12.6. Add 100 to both sides, 100 plus 12.6. So someone would have to score above 112.6 on their IQ test in order to be at that 80th percentile of the scores. And so that's been more difficult, having to work from the table back to the z-score and then back to the x values. But we're still using the same formula, we're just going down opposite path.
I picked the 0.85 that have been counted.
Yeah, I think we'll probably give credit there because you're still looking at the right place. You're just a little off.
Okay.
That's really fine. Okay, let's go to page 23. So this is Tuesday's work, but if I feel like we're a day ahead, we can get through page 23, 24. Tomorrow we'll just focus solely on review. Okay, so go to page 23, read the problem, see how much you can begin to do, and then I'll follow up with the steps. Okay, part A, what's the percentile rank for Jack's score on this test? Percentile rank means Jack scored as well or better than the percent of students taking the test. So let's find the Z-score. There's my X, there's my X bar, and there's my sigma. Okay, go to your table, 1.53, that's on page 3. 1.53, 0.9370. It's asking for the percentile rank, so I gotta convert that probability to percentage. So that 148 is the 93 percentile, 93rd percentile. Okay, so now part B, we're working backwards. Okay. So for Jill, we're going to start at the 67th percentile, work to the probability, use the table to figure out the Z-score, and then cross multiply to solve for the X. So we know that 67th percentile means a probability of 0.67. Anything from 0 to 0.5 is page 2. Anything from 0.5 to 100% is page 3. So you know to look on page 3. 0.67. Looks like I found one that lands exactly there, right? So 0.44. These scores 0.44. We go to our formula. We're just inserting for a different variable here. We have the Z-score, we have X bar, we have sigma. We're just solving for X. Cross multiply. Solve for X. So if Jill scores 131.6 on this test, then she's going to be at that 67th percentile. Okay, same idea, same process for all these problems. So go down, each of the problems. I'm gonna have you guys try it, but I'll also show the answers and kind of talk through the steps after you guys try it. Okay, so go ahead and start number 2.
Mr. Yang,
Mhm.
when do you subtract the percentile by 1 again?
Yeah, if you see the word more than,
Yeah.
but fewer than is safe. That's that easy. Yeah, so more than is where you gotta do some additional work. Less than is the easier one. For number 2A, everything is given to you. Just have to find the z-score. Look down your chart, and then you can keep whatever you see because fewer than is what is going to match directly with what z-score is giving you.
Right. It's asking for percentage. The same thing as this, like it's asking for percentile.
Yeah, percentile.
Okay, so it's just, I'm not supposed to subtract by 1 or anything. I think it would be 84.1.
Yeah, that's right.
Okay.
That's right. Mhm. Okay. For part C, you see the word more than? Whatever you get from the table, you gotta subtract from 1 because your table is only gonna give you less than. If you want more than, I gotta look at the other side of my chart, so one minus. Part C is where you have to work backwards from, so 38.85% converted to a probability, 0.3085. Look for 0.3085 in your table, and then the z-score that's associated with it is negative 0.5, and then from there, if you know your z-scores, x bar and sigma, you can cross multiply and solve for x, figure out how many days. Okay, let's see if we can get through both pages here. We'll try to get through both page 23 and 24. All right, if you're good with 2, go to 3. Is anybody still working on number 2? Okay, check your answers. Problem 3, if you've done that already. I'll yeah, I got it up. Yeah. I would put it up. Okay, anybody still working on number 3? Go to the next page. Let's see if we can get through the next page in the next 5-7 minutes. Anybody still on number 3? Um,
150. It's a.
Okay, okay. That's, yeah, that's, because you rounded it a little differently, was that right?
Yes, maybe.
That's fine. If it's because you rounded differently, then also give you credit because you're showing the word to understand it.
Oh, yeah, I can, that one.
That's fine. So, we can try.
So are we, so we are supposed to round it. It's a repeating.
Yeah, we're supposed to round it, but I understand if you did not, still, we still need the steps. For number 5, you just have to make the adjustment that after you find your probability, you gotta subtract from 1, because at least 92 means 92 or higher. My table is giving me 92 or less, so I gotta subtract from 1. And then here, probably student will get a B, because we're going to the 10th. A 79.5 is actually considered a B, because it rounds to an 80. And 89.4 is considered B, because it will round down with that decimal. So we're looking at really, rather than between 80 and 89, if we're going to the 10th, it's actually 79.5 to 89.4.
We explained it like right now.
Because a 79.5, the breakpoint will still round up to an 80. But the 89.4 and the breakpoint will round down to 89. So technically, they still fall in that B range. Okay, let's just get through number 5. Check our answers. We're ahead, which is good. We'll finish up 6 and 7 at the beginning of class. I'll give you the quiz reviews and we'll go through the quiz reviews. Yeah, so just get to 5, get through 5, and we'll do 6 and 7 tomorrow. Yeah, I rounded up to 1.82, but if you didn't, you'll still get credit. Get the phones. I'm trying.
Oh, wait.
There's a.
Yeah.
Let's go. We have to have.
Not just that, I've been subtracting by 80.
I heard it.
That's probably like a little bit off every time.
I do.